Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important electromagnetic theory question, that is from Ampere's law, right? So, based on the application of Ampere's law, that question I took in this way. So, please try to understand how we have to solve this question once you have to see. CSIR December 2016, there is a question, that is the Ampere's law question. According to your syllabus of the electromagnetic theory, what is the first topic? Electrostatics is there. Electrostatics, I told some questions, and Gauss law and applications also I told, and some question. This is the second law. In between, Coulomb's law also is there. The Coulomb's law, Gauss law and applications I told to you. And after finishing the Gauss law, according to your syllabus, there is a Poisson equation and Laplace equations are there. So, from the Poisson equation and Laplace equation also I told some questions, and the subsequent topic is boundary value problems. The boundary value problems of the electrostatics method of image problem. So, those problems we discussed, whatever the areas are there, those areas are we discussed in the YouTube also. This is the 29th class from the electrostatics theory only. So, after finishing the electrostatics, we have to enter into the magnetostatics. The magnetostatics, so we discussed about the introduction of the magnetostatics, and the latter I am taking into a, so what we have to discuss, so low range force and so helical shape, how it is coming, that one we are discussing. The latter we have to enter into the magnetic field. So, due to the Biot-Savart law, one question I told you. So, now today in this class we are going to discuss about the Ampere's law application. I am going to discuss to you. So, very important, you have to concentrate on this. A parallel plate capacitor is formed by two circular conducting plates of radius a separated by a distance d. A parallel plate capacitor is formed. A parallel plate capacitor is formed by two circular conducting plates of radius a separated by a distance d. So, when d is less than a, so this d is very less than a, it is being slowly charged by a current, so that is nearly constant. At an instant, once you have to take it as a parallel plate capacitor, that is a cylindrical plate you are able to take. When the current is I, the magnetic induction between the plates at distance a by 2 from the center of the plate you have to see. So, this is the shape they are giving. This shape is a, which shape you have to take? First, once again I have to draw the diagram, then a little bit you able to understand. Suppose you have to take, it is a capacitor plate, you have to take, this is the capacitor plate. Now, the current is passing through this capacitor plate. How much current is passing through this capacitor plate? High current is passing through this capacitor plate, right? So, high current is passing throughout that. So, what is the area radius of this capacitor plate is equal to a. Now, we need to calculate the magnetic induction. Where we have to calculate the magnetic induction? So, we have to calculate a magnetic induction at particular point. So, at particular point, this is the r distance is there. So, this r is equal to how much distance? The distance is a by 2. So, we need to calculate the magnetic field, we need to calculate, that is the magnetic induction we need to calculate. This is our ultimate goal, right? So, according to the diagram we have to write it is, once again you have to see, a current is passing through this cylinder. This is a uniformly charged cylinder, right? That cylindrical area radius is equal to a. So, in the cylinder I have to construct one small cylinder, that is r radius cylinder. That r is going to take it as a by 2. So, at particular point P, you are able to take it particular point P, we need to calculate the magnetic field. So, magnetic induction we need to calculate. How we have to calculate? First we have to apply the Ampere's law, later we have to see. First you have to say applying the, to find the magnetic field there is a procedure is there. To find the magnetic field there is a procedure is there. How we have to apply the electric field through the Gauss law, same procedure you have to follow to find the magnetic field, so through a Ampere's law. The step number 1. So what is your step number 1? First construct the Amperean surface. First construct the Amperean surface. You have to construct Amperean surface, right? So you have to construct a Amperean surface, you have to construct. So this is the Amperean surface. Here dl and magnetic field are same direction. dl and magnetic field are same direction. In between the dl and magnetic field, angle theta is equal to 0. So therefore cos theta is equal to 0. We have to get it clear. So now you have to write, this is the, so already we constructed. So this is the construction of which one it is? Ampere's loop. So this is the Ampere's loop we are constructing. So this is the step 1. Based on your case you have to see. This case is r is less than a. Inside this is the radius you have to take. Now step number 2. What is your step number 2? Your step number 2 is find the magnetic flux. Find the magnetic flux. How we have to calculate the magnetic flux? Magnetic flux is equal to integral B dot dl. Wherever you go on the Ampere's surface, at all the points the magnetic field is same. So that's why you have to take the magnetic field outside. So integral dl is equal to, this is the cross sectional area of that one. So the cross sectional circumference of that. So what is that cross sectional circumference of this? You have to take b into 2 pi r. You have to take, this is the circumference of the cross sectional circumference of a Ampere's loop. So this is the magnetic flux value we have to write it is, this is a magnetic flux. Now you able to see the step number 3. So what is your step number 3? Find the current enclosed through this Ampere's loop. Current enclosed through this Ampere loop is equal to integral j dA. So integral j dA you have to take. So this current density is equal to j, you have to take outside. Sometime you have to take integral dA. So integral dA is equal to, already you know this is the area of that Ampere loop. So that area of the Ampere loop is equal to phi r square. You have to get it. Which one you are getting? Phi r square you have to get. So after some time, so what is going to take it as a, so the step number 4. So what is your step number 4? Your step number 4 is equal to apply the Ampere's law. Apply the Ampere's law. What is your Ampere's law? First you have to apply the Ampere's law. First you calculate the Ampere's law. That Ampere's law is equal to, how we have to apply? The magnetic flux is equal to mu naught times of current enclosed through that loop, that is the Ampere's law. What is your magnetic flux? B into 2 phi r is equal to mu naught into how much current is enclosed? J into phi r square. This is the current enclosed. Phi 1 ja get cancelled. Therefore the magnetic field is equal to mu naught j r square is divided by 2r. 1r get cancelled. Therefore mu is equal to mu naught jr is divided by 2. Along which direction it will go? Because it is a wire, that's why you have to take it as a phi cap direction you have to write it is. But you know that, so instead of I we have to write it is j is equal to I by a. So therefore I is divided by a is equal to, we have to write it as phi a square. A is equal to phi a square. So you substituted this value. Therefore B is equal to mu naught is divided by 2 into j is equal to phi a square into r. So you have to write it is r as it is, you have to write, that is the phi cap is there. Is there any cancelling terms? So there is no cancelling terms. B is equal to mu naught I is divided by 2 phi a square into r into phi cap. This is the magnetic field at particular point r is equal. But your r is equal to, what is your r? Your r is equal to a by 2. So therefore you have to substitute your b is equal to mu naught I is divided by a by 2 into 2. So phi a square. So 1a get cancelled, that phi cap. So therefore b is equal to mu naught I is divided by 4 phi a into phi cap. This is your magnetic field at particular point a by 2. So like this, there you have to calculate. You see the answer. What is your answer? You have to see. Mu naught I by phi a is not correct. Mu naught 2 phi a is not correct. Mu naught I by a is not correct. Mu naught I by 4 phi a is correct. Like this we have to calculate in our competitive examination. The magnetic field at a by 2 is equal to mu naught I is divided by 4 phi a. So based on your problem, you have to do by using the Ampere's law, we have to calculate. So like this we have to calculate the answers. If you really likes my teaching, we started the CSIR and GATE physics content in our app. Our app name is Quantum Online Academy app. My mobile number is 9908437460. You have to go to your Android mobile phone. From your Play Store, you download the app, this Quantum Online Academy app you have to download. After downloading the app, you log into our app. Once you have to log in, enter, you have to see the stores. So the stores will display like this. The CSIR and GATE physics course will display. This is the popular course, and so JL physics and DL physics content is there. Not only that, individual papers also is available. Mathematical methods of physics. Mathematical methods of physics. This paper is completed. Now entire portion is available according to your CSIR core and advanced. If you want to take only mathematical methods of physics, you have to take this one. The classical mechanics also completed core and advanced. If you want to only classical mechanics, you have to take this one. So electromagnetic theory also, almost electrostatics is finished. Magnetostatics we started. So these classes are now live plus recorded classes are going on. If once you have to attend to the live, after some time it is recorded. So that recorded version will be available up to the 1 year if you have to purchase these courses. If it is CSIR and GATE, so that is 2 years validity course. This is the 2 years validity course. If you have to join in this course, it will take the time to teach to you. 1 year it will take. So that's why I kept 2 years validity. Clear? So whenever the notification will come, we too don't know, but the CSIR notification will come at least per annum, one time also it will come. So that's why I have to take this course. So this syllabus is the same syllabus for JL and DL also. If you want to take, you have to take this course also, right? So otherwise you have to negotiate with me, you have to join in this course. This course is very much useful to you. So please share and subscribe our YouTube channel, and you have to inform to your friends also who are there in the physics fraternity. You have to inform them, so those people will get benefited. Thank you so much.